Good day, everyone, and welcome to week 7 of ordinary differential equations. So in this week, we are going to learn how to do modeling with second-order differential equations. And so first of all, please note that to understand today's lecture, it is very, very important that you remember the material of the two previous lectures very well, right? So you need to know how to solve homogeneous differential equations with constant and coefficients and non-homogeneous equations. So basically, recall that in order to solve a homogeneous linear differential equation with constant coefficients, second-order differential equations, you need to write down the corresponding characteristic equation, which is just an algebraic equation, a quadratic equation, and then you need to solve it. Right? So if the discriminant of the characteristic equation is positive, then it's one case. If the discriminant is 0, then it means that there is only one root, a real root, and it is a repeated one. So then we have a different solution pattern. And in the third case, when the discriminant of the characteristic equation is negative, then we have a completely different case, and then we have the solution is going to have cosine and sine. Well, so another thing that we learned in the two previous weeks is that suppose that we have a non-homogeneous linear differential equation, then its general solution is going to be constructed as follows, right? So it is the sum of a particular solution plus the general solution of the corresponding homogeneous equation. So in a way, it is very, very similar to what you learned in linear algebra 1, right? So when you talked about solutions of systems of linear algebraic equations. Okay, one more very, very important thing that we learned in the previous weeks is that if we have a non-homogeneous linear differential equation, then we can solve it using variation of parameters, right? So suppose that somehow we know the general solution of the corresponding homogeneous equation, then changing the two constants, C1 and C2, to parameters, to variant parameters, that's why it's called variation of parameters. So changing constants to functions of t, we can find a particular solution of the corresponding non-homogeneous equation. And it was a very, very lengthy and tricky computation, and then in the end we got this result, the specific formulas how you can find U1 and U2. Well, and finally, I want to give you a little bit of a real-life context. So today we are going to review models with second-order differential equations, which in nature they are usually related to some kind of vibrations or oscillations. And for instance, we are going to look at the notion of resonance. And the interesting thing about resonance is that, again, it is very, very, very common in nature. And for instance, some resonance disasters have been known, and here is probably the most amazing one, Tacoma Narrows Bridge disaster. So let me show you a few moments from this video, but I suggest that you view the full video at home, right? So it was this bridge, and somehow its internal oscillations, they came in resonance with external oscillations driven by the wind, and this is what actually happened, and eventually the bridge collapsed. All right, basically this was the motivation behind today's lecture, and you can of course view it at home, but that's the end of